Morning, everybody. It's a great pleasure to be here in this, let's say, vibrant community. So we are not part yet of the HL, but we are searching for collaborations in this open source community, because where I'm active is this European Software-Defined Vehicle of the Future initiative, and that's something which I will present you or give you an overview of what's going on there in the next few slides. So, short, what I will talk about in these 10 minutes, it's about the SDV initiative, what it is, where the partners are, then some motivation and the transformation path, so why we have founded this, let's say, consortium and what we try to do, then something about the first projects which are started, and then something about the collaboration model. That's also why I'm here, to see how you work in your group. So this initiative you see here, it's from most of the European countries. There are partners there, so they are coming from all the different domains, let's say, around the automotive industry. We have technology providers in there, the OEMs are in there, tiers are in there, tool vendors, academia are in there, semiconductor industry is in, so it's really also this industry associations like AUTOSA, COVESA, Eclipse, everything also is, let's say, coming together to tackle or to take over this challenge about the software-defined vehicle and this digital transformation path, let's say, where we are now, because there's some kind of renaming that, not software-defined vehicle, it's more digital mobility of the future. So what's the main motivation? So all these people are coming from, let's say, traditional car manufacturing process, very simplified. They look what's there, they reuse that, they add new ideas, provide new concepts, maybe good concepts, sometimes makes our lives harder. They produce prototypes, they write requirements, design documents and so on. Then they go to the tiers with that. So there's some commissioning, the tiers starting development parts, pieces, software, whatever. They deliver that, start of production, a huge integration process started. Then it's done, and that was the end for the OEM, never seen the car. So these new hyperscalers, they're coming from, or they have a different approach, let's say. So now and in the future, what they did, so they act much more as digital service provider. So they are not focused on the vehicle itself, how it looks like, how many PS it have. They are more interested in this relationship with the customer. So they say, okay, we want to stay in relationship with the customer. We want not only sell him a car, we want also use this huge set of information where the vehicle is now embedded in this cloud environment and add additional, let's say, business models to that. So that means they have a relationship during the whole life cycle of the vehicle and later on too, because the software is still developed, deployed to other cars and so on. And the vehicle itself, it's much more, let's say, one more device, complex device, not a smartphone on wheels. So smartphone is install the software, mail address is the integration effort, but here it's a huge one. But if you think about this digital device, which is now in the internet, and you offer services for that, how it looks like. So at the moment, we have some navigation apps where we can say, I want to drive there, and then it shows me some charging station, for example. But the really good ones, they say, okay, there's a charging station. That's the time where you're there. I reserve a slot for you. So sometimes you come there and there are 6 cars in the queue before you. You have to wait. Maybe it's also taking some contracts with the cheapest energy provider and so on, and there are really services behind. And that's this change from this app-centric silo, let's say siloed development where we're coming from, to this data-centric approach where everything is based on data. Everything is the cloud. We take the data, combine it, did some, let's say, cool stuff with it. So to tackle these challenges, the European Commission takes some money together with the industry and start some, let's say, research project series. The first one we have started where I'm active is this Federate project. So Federate is not a development project where we develop software or some solutions for this. It's only an, let's say, steering coordination action where we collect requirements, where we look at what is needed, how building blocks could look like, how they could be described. There's a lot of effort to get a common understanding about the building blocks we use, because it depends if they're from the, let's say, semiconductor industry, software developer, car OEMs. If you have one word, there are different pictures in mind, what we are talking about. So that's everything which is worked out in Federate. So that runs its 1.5 years. There are some recommendations out, there is a roadmap out, And one of the recommendations was that we have defined, let's say, a layered architecture as everyone uses it. There is hardware, there's operating system, hypervisor, middleware, applications on top. There are processes. And we say, okay, in all of these steps, we need to do some changes in our thinking, in our, let's say, how we tackle this. We say, okay, the first thing is we need to come up with a project where we talk about this hardware abstraction, because the software should be developed independent from the, let's say, hardware. Should not be of interest of a software developer which takes some data in the cloud, some new applications to have, or that he should not need understand what's below in the vehicle, let's say. In this project, so it's only a few words, there is a lot of more effort ongoing, so there's a project around 80 million euros and more. We're talking about this hardware abstraction, so we, with our company, working with the Xen hypervisor. That's also why I'm here, to see what you guys did. There's something about vehicle abstraction. That means they're working with VSS, so they say, okay, hardware abstraction is one layer. The other thing is this vehicle API. And yeah, we should use this VSS and extend it and put it at the bottom at the vehicle, so that they say, okay, at the moment they have several CAN matrices. Let's say there's the speed is integer, has this name, that name. It's a lot of integration effort, mapping and wrapping to get the information up. But that's more this work we did here to harmonize that stuff, to harmonize the APIs and so on. The next thing we talk about is this middleware stuff. So this is a project started 2 weeks ago, that Shift to SDV. In Shift to SDV, we say, okay, here we're working with the hardware abstraction. We want to offer APIs, where they or whatever it will be at the end. And on top of that, we need some middleware which makes it easy to access all the data in the vehicle, the communication, to the cloud, wherever. We need different approaches to, let's say, monitor the vehicle. So it's not that you debug it, trace it, and then build your product deterministic and put it to the car. Now we are in a dynamic environment. Everything needs to be observed during the whole life cycle, let's say, to figure out if there's new software deployed, what's the behavior and so on, how to react on that. And at the bottom, there is another initiative where we're working together. It's the RISC-V initiative. That's the development project for all these hardware guys, let's say. There are some issues with this, let's say, regulations or import regulations from China and so on. And then the European Union says, okay, RISC-V is a good idea to have some kind of independence from that. And there are also upcoming projects where we say we work out and federate to say, okay, that's the next thing we need and the next thing we need. And that's a project landscape, so where building blocks are developed, and these building blocks, they have to be worked together, and that's the tricky part. So in this SDVOF initiative, there we have a lot of partners. There's AutoSign, Covesa, Eclipse, and so on, also these initiatives. But these research projects, you know, if there are hundreds of people starting development, if it is not, let's say, harmonized, so the API is not harmonized, the target environment isn't harmonized, at the end, you got several solutions which do not work together, and you have a lot of integration effort to use that. And for that, in parallel, so the OEMs say, okay, we need some solution for that. And the first approach we want to try is this S-Core. So S-Core is under this Eclipse umbrella, let's say. And what the OEMs did first is they say, okay, if we use open source software, so that's needed because they need to understand what's in the vehicle, that they can react, that we have heard yesterday to this Cyber Resilience Act, for example, within a few days. Then we need some quality in the open source software. As we see it now, the Linux kernel, we have tried to certify it or something else, but there are no requirements, design documents. You have no idea what's in the code because what was the mindset of the developer to provide the solution. And for that, they have set up this project. It's only an integration project, also no code development, but all the processes are there. So they have defined ASPICE process, these ISO processes for safety and security. If it's the right way, let's see if the developers really align to that. But that should be the integration path and all the projects around. Now we synchronize with them. We try to bring together this, let's say, target environment, all the APIs and everything is needed to harmonize that so that we can contribute pieces of software. They can be taken, build a stack of it, an open source stack, can be taken by everyone or should be taken by everyone, and then be customized by the OEMs, by IDs, whatever, and then put it in the car. But with a quality which is automotive grade, so really also certifiable. And that's the hardest thing, I think. That's where we have to learn for other open source communities, how they work together, how it fits there. You see there's also AutoSAR in, there's Covesa in, so in AutoSAR we have not a track also to harmonize that with them. If that will really be a success story in the future, we will see. So there are a lot of challenges we have to tackle. So the communication effort, what we figured out in the open source community is really high. So it's very easy to develop some piece of code with 5, 10 people. But if there are hundreds of people and companies and you have to bring them together, yeah, it's really challenging. So we have to learn a lot how this fits. Next thing is, so the OEMs are very good in integrating parts, but they have no software experience. They have not the skills. So now they have requirements. We have to align them. We have to harmonize them. So we have to, a lot of things we need to bring together. Yeah, so that's the last slide for this, let's say, short introduction about this software-defined vehicle of the future initiative and all the projects which are ongoing, coming, and what's going on in Europe, let's say, to tackle this challenge and really speed up this development process, provide, let's say, engineers which are ready for the future, which have the skills to do that, and so on. Are there questions? Yes, please.
Where do you see AGL in this?
Where?
Where do you see AGL?
AGL. So, if I show you these pictures from the projects, then you see this Halfo SDV. Halfo SDV is working on this hardware abstraction, where we're working with operating systems, where we're working with Xen, but we have also a lot of, let's say, proprietary companies in. There is Cisco with BikeOS and these hypervisors. But what these S-Core people did as a first shot was, they said, this is the architecture. We are interested as first step in this middleware. So they draw this picture that needs to be harmonized, that needs to be updated. So that was a first shot. So that's not the final version, let's say. But they said, yeah, QNX is the solution. We say, okay, if we now in an open source environment and so on, then QNX is not really a solution for that. So we should think about something in this open source environment, and I think automotive grade Linux is a very good choice to integrate it there, to say, hey guys, we're working on the middleware, we're working with Xen hypervisor, we're working with all that stuff. There is also an open source, let's say, operating system, which is proven in use by, I've heard a lot of Japanese companies, they use it in the infotainment and so on. Why we did not go in this direction? And that's where I see AGL Linux, that's why I'm here, to listen and hear what you do. In this next discussion rounds, I will try to push that a bit in this direction. So the first thing they did, so as we use Xen hypervisor, is they say also, yeah, Xen is a good solution instead of, let's say, QNX. But I would really, it would be appreciated if we can also collaborate together to say, okay, it's a European initiative, and now let's extend it to a Japanese, worldwide initiative where we really work together on such things where we are not, which everyone needs, where the user did not see that, what's within the vehicle. So if you say you're the only company who can develop it, then maybe it's some competing stuff, but it isn't. Let's say it's an operating system. There are several out there. And what we have did is also some kind of investigation of other, let's say, continents. And in China, they take this challenge with QNX also, and they develop their open source operating system. There's HelloOS, there are a lot of SymfonyOS from Huawei, and a lot of operating systems which are now competing with QNX. That's why they also go a bit in this direction, the opening at the moment, because there's pressure on them. But I think that AGL would really can play a great role in such a stack.
All right, I think time's up. Thank you.
Welcome.